Hey y'all! Welcome to the 7th lecture of the Intro to Backend course. We're nearing the home stretch. The hack challenge is almost here, so we will be giving you guys more information on details for the hack challenge soon. Yeah, be on the lookout for that. There's not going to be any more assignments for the course. All that's left is the hack challenge and feedback forms. If you guys haven't done those already, make sure you go back and do those. So, these last 2 lectures could be considered optional. If you want to include authorization on your hack challenge, this lecture is perfect for you. Or, if you just want to understand how authorization works, right? Because most applications have some sort of user identification of some sort. Totally stay tuned because this is really important for that. All right, let's dive right into it. As usual, we're going to recap just a little bit to tie into what we're doing today. In this class, we've taught you guys about HTTP, right? Clients will send a request to the server, saying, I want my Spotify playlist. It's called this. This is the playlist ID, right? Because that's probably how it's stored in the database. And then the response will say, sure, yeah, here's the playlist, here's the songs, status code 200. We did it for you, it all went cool. But, applications somehow need to differentiate users. If we think back to the CMS assignment we did, right? The only way we really figured out who was sending a request was from the IDs people passed in. That's not the most secure thing in the world. If people somehow got a hold of someone's ID, or, they're just spam trying different IDs if you're literally using a numeric ID system like we were there, which is also a bad idea. People could somehow, fake being an instructor to get into the server. That's not something we want, right? So, to avoid that, we need some better way of identifying who's making requests. That's the big problem. How do we verify who's sending the requests? If we look at, the post assignment we had before, the only way we were really doing it is we said, hey, when the front end sends us a request, they'll just tell us who they are, and we'll just trust them. Honor code. They'll tell the truth, right? If this person tells me they're Rahi, then, they probably are. I should totally click on this not-so-suspicious link that I'm being sent. Same logic behind when your Facebook Messenger account gets hacked, right? And then you send your links to a bunch of those hacked links to a bunch of friends. The idea is if they hack one person's account and send it to friends, they might trick your friends into thinking it's really you and they'll click on the link. We don't want our servers to be fooled like that. How do we authenticate? Well, we could include more metadata, right? Metadata is what happens in the request headers, in response headers. And so what we can do is, I'll go a little bit more into what headers are in a couple seconds. Stay tuned for that. But what we can do is we can just say, hey, front end, send us proof of who you are, right? You're claiming to be Rahi. Just give us your ID, maybe your username and password or whatever. Prove it to us. So, maybe you register with your email and your password and you sign up, right? The credentials get sent to the database, they're encrypted, and then they're stored, right? Because obviously we don't want to store passwords outright. Actually, maybe that's not so obvious. Let me go into that. There are a bunch of problems with storing passwords outright. The super terrifying one is a lot of people use similar passwords for different websites. So if your Google account, say, gets hacked, or if Google's servers somehow get hacked, and they were just storing passwords raw, all of a sudden these people might have your password to so many different websites that they can try hitting. That's bad. So they get encrypted in some different way instead. There's a plethora of reasons that we want to store things encrypted, but the main thing is we want to somehow distance this information from the user itself. So we send the username and password to the server stores their credentials. Perfect. Now when we want to re-log in, we just type those passwords in, send the credentials to the database, and then credential just searches through all the people they've stored and says, hey, found this user, they've registered already, we can send back an OK response. One way to do this is in HTTP request headers. If you think back to the very beginning of the class, I mentioned the request body is not the only way to send information. You can send information in request headers. And so request headers have a lot of kind of metadata about a request, which is rather than the actual information you want the backend to work with, it's information about the request itself, right? So, there's a bunch of different things. There's content type, cookie, user agent, authorization, et cetera, et cetera, et cetera. The two that we will be focusing on, at least for this lecture, are cookie and authorization, right? Those are the main things we'll be caring about. So, just as an example of request headers, we can see, all of these things. We have cookie over here. We have content length. We have the content type. We have the method, right? Post. Here's the website we're hitting. Here's the whole path. There are three different kind of ways of maybe doing authorization. The first one is just basic authorization, and it has some problems, but it's really simple to implement. Let's look into that. You literally just encode the username and password, and note the use of the word encode rather than encrypt. Encoding something, it's a lot easier to decode something than it is to decrypt something. Encoding is really just making something smaller, right? It's condensing something into some sort of string or different format. So you encode the username and password, the front end stores those credentials, and then with every single request to the server, we get sent your username and password. So then the server just checks to see if those credentials are in the database, and if they are, sends an OK response. Well, this has a lot of problems. But we'll go into those in a second. Let's just look at an example for now. We have this GET request to some website on Google. And then we look at this authorization header, right? Because this is what a header would look like. Oops, did not mean to click there. So this is a basic header, right? And this is literally just the encoding of the username and password combined. Remember, this is an encoding, not an encryption. It's just kind of converted your username and password into a smaller condensed string, and it'll be very easy for the backend to decode this information. So now what the process is the client registers. The server says, okay, I'll create a new user in our databases for you, and then I will return whatever created response you wanted from creating that user. Okay. Oops. Success, new user made. Now, whenever you want to access information again, the front end has already stored your username and password, so it sends that over to the server. The server says, I got you. Let me decode these credentials. Now it's split it up into the username and password, right? Because before it was kind of combined into that one basic authorization header. Checks to see if that password corresponds to that username, and if it does, it'll return a response. Success. So this is really simple, right? It's not that hard for the backend to code. Any front end can really do it, right? Because the server is going to send you back exactly what you need, and any client can just hop onto your website and immediately get to work on it. But every single request you send has the username and password just exposed. It's not impossible to monitor traffic on a network. People could very easily just steal your username and password in that request. Not great. Unless you're using a VPN or something. Another problem is you're just storing your password on the front end. What? That's sure, you might think, okay, that's fine. It's my phone. I can just leave things stored there. I mean, I guess, but it's better to have things as secure as possible. And if your phone is just storing your username and passwords willy-nilly, that's not the most safe thing in the world, right? Maybe you get some virus on your phone rather than on the website, and now all of a sudden, if everybody used BASIC, all of your usernames and passwords are exposed, right? It's too condensed. The other thing is, we don't have control over when these get deleted. The front end might occasionally delete it itself, which is better. Or if you close your browser, it'll get deleted, stuff like that. It's less consistent. If you wanted a specific timeout, for example, rather than having people log in every time they open a new browser session. Sorry. And the final thing is, if you're not using HTTPS, you really run into the problem I mentioned earlier about your stuff just being exposed. HTTPS is the Hypertext Transfer Protocol secure. Most sites nowadays will use HTTPS, but if you haven't registered your site with HTTPS and haven't gotten, that security set up, it's really a problem with BASIC. And it's also just depending on somebody else to take care of security for you, which, is fine in a lot of circumstances, but, if you can make it better, you should. So, the next authentication scheme is the HTTP session. In this case, you first send your username and password to the server to create the user. The server says, okay, and then it creates the user. Then, after that, you log in by setting your username and password again, so that's 2 times so far. The server validates it, and then instead of sending the user back, it sends a cookie back. The cookie is then cached on the front end, so now instead of storing, say, your whole username and password, you're just storing this cookie. And then the cookie is then sent on every request to identify the user. And what the backend can do is make the cookie expire whenever it wants, rather than having, it just expire whenever you quit the browser. So, this time, you encode the username and password. This is exactly like BASIC for creating a user, so I'll just, go over that. That said, we should look at this session ID. What happens is, you've created a user session in the backend when you log in, and this is the session ID that'll kind of get stored in the database, and it checks that alongside your cookie. So you can see that this is being stored in your cookie, and so you go to the session ID, and then the database says, hey, is this a valid current ID or has it expired? Right? We can see that there's expired session information. So, client registers, server creates a new user, then creates a session and returns the cookie. And we can see that the front end, in this circumstance, no longer has to store the username and password. So the server sends the cookie back to the front end, and that's what it stores instead. Then, on all subsequent requests, the client will send the cookie. The server will check the session ID to make sure it's fine, validates it, and then if it's valid, we'll return a response. But what if it's not valid, right? What if the session's expired? Then we just return an invalid response saying, hey, that's a bad cookie. You have to log in again, right? If the session's expired, we tell the front end, hey, just log in again. Then, validate the credentials, create a new session, return a cookie. And now that we've made the new cookie, we can send it back. So we can see that, it's a little safer from the perspective of the cookies are going to constantly get updated, right? So even if someone manages to steal one of your cookies, you'll need to log in again, and they won't have your login information. So they won't be able to have access to your login on the server anywhere near as much as if they had stolen directly your username. So, like I said, you don't have to continually send them for credentials, and you can figure out what you want your expiration time to be, right? If you make your expiration time really, really short, like, a cookie expires within like half a millisecond, they're just going to have to log in on every request, right? That's essentially just doing BASIC. Or you could make the expiration time super long, but then it's less secure, right? If someone steals your cookie, they just have access to your account for forever. Some problems. For one, it's saving the session data in the memory of the server. So where the session ID is actually stored is usually in the backend's raw memory rather than in the database. That doesn't scale super well. If you run out of memory on the server, all of a sudden you just can't have that many more users on using your site at one time. And also, if your browser, if the client deletes the cookies from the browser for whatever reason, they'll have to re-authenticate. The final one is the one we'll be teaching you in this course, which is HTTP token authentication. So with token authentication, like before, you send your username and password at the beginning. Then the server checks the credentials and validates them. Instead of sending a cookie, it'll send an access token, which the front end will cache, and the access token will be sent on every request to validate the user. But wait, this sounds almost identical to cookies, right? What's the difference? Well, let's get into that. For when the authorization is slightly different, we can see that it's using bearer instead. This is actually just an encrypted token that the servers come up with for you. Here's where the differences really start. Access tokens are stored in the database rather than in memory. When I say memory in this case, by the way, I mean RAM, so like random access memory, rather than hard disk memory or wherever your database is storing things. In the case of SQLite, it's being stored on disk. Postgres is actually storing it on like a whole other server. Anyways, because it's stored in the database, all of a sudden it's a lot more scalable, right? You can scale this as big as your database can scale, which is generally more than your memory can, or at least your server memory. The other thing is, like cookies, access tokens will expire after a while. So, like cookies, isn't a super big problem if you expose an access token once in a while. But the really nice thing is we now have a refresh token. So the idea behind a refresh token is when you generate an access token, you also generate a refresh token. You send that along to the client as well. Whenever the client's sending a request, like before, the backend will check to make sure that the access token's fine. If the access token isn't fine, it'll check the refresh token. And if the refresh token is valid, then it'll just automatically return a new access and refresh token for you. So it really decreases the amount of times users will have to log in and expose their username and password. Let's look at an example. Well, first, again, more stuff in the database. It's really not that hard to implement, right? You just create a new table that references users' IDs, has an access token when it expires, and then another thing for the refresh token. So the client registers. This is, pretty much the same as before, but they'll create new tokens, multiple this time, the refresh and the access, and return them. Then, when the client wants to set more information or log in, they get sent an access token. The server checks to make sure the token's valid, does whatever the client wants them to do, returns a response, right? If the token's invalid, they'll return a response saying, hey, invalid token, which the front end can then say, all right, I'll send the refresh token, right? Not your username and password, just this one refresh token. Then the server will check to see the refresh is okay, and if the refresh is okay, it'll create more tokens. Oop. Front end has new tokens with which to work. You might be wondering, hey, what's the difference between, sending refresh tokens and just having users permanently logged in? Refresh tokens and access tokens will keep getting changed. That's the main thing, right? If you just made a cookie last forever, well, if that cookie gets exposed, the client's out of luck. If an access token gets exposed, it's not that bad because all the client does is refresh it once. And they're refreshing a lot less than they're using their standard access token. So it's a lot less likely that the refresh token will get exposed. So, like I mentioned, it's way more scalable than session cookies because it's being stored in the database. Like before, you can tune the expiration time to figure out how long you want it to take before it expires. And you very rarely need to send user credentials. You need to send user credentials when it's been so long that the refresh token has expired and when they start using different devices, right? Because, the front end is a device. If they have the refresh token stored on one device, that's not necessarily going to transfer over to another one. It can. A lot of Android phones can transfer things between. I think Apple is pretty good about that too if you have a Mac. But, So those are the 3 HTTP schemes. In the demo, you will be learning how to implement the HTTP token scheme. So, head on over and watch that. I hope this optional lecture was interesting for you guys. Yeah, anyways, good luck. By the way, just some other things. A lot of times people don't implement authentication on their own. You might use something such as Google OAuth, which is Google's own authentication library that you can use to say, hey, you can sign in with your Google account. So that's how a lot of apps that you've seen do that use it. They use Google's OAuth stuff. That's a little too complicated, I'd say, for the hack challenge, but definitely look into it if you're interested in authentication. Anyways, have a great day, y'all. Have fun in the demo.